Before computers decided everything, engineers built bulldozers with one rule: make it unbreakable. Thick steel frames, massive drivetrains, parts designed to outlast the men operating them. These machines weren't just built to work, they were built to survive explosions, rock slides, heat, cold, and decades of abuse. They were heavier than necessary, stronger than required, and nearly impossible to kill. Many are still running today, long after their replacements failed. This is the story of 10 vintage dozers that were over-engineered to perfection, machines so well built, time itself couldn't wear them out. Number 1. Letourneau D10 and D12. R.G. Letourneau never thought like a normal equipment manufacturer. While others refined mechanical drivetrains, Letourneau asked a dangerous question. What if a bulldozer worked like a locomotive? The result was the D10 and D12 electric drive crawler dozers. Instead of a conventional transmission, these machines used massive diesel engines to power generators, which fed electric motors driving the tracks. It was mining technology transplanted into a crawler. This system was absurdly expensive. It was heavy, it was complex, and it was nearly indestructible. Electric drive meant no gear shock, no clutch abuse, and no traditional transmission failures. Torque was smooth and relentless. The tracks pulled like they were connected to a power station. These machines could push continuously under load without the drivetrain fatigue that crippled mechanical systems. The frames were built like bridges. Every structural component was oversized. These dozers were not designed for job sites. They were designed for open-pit mines and mega earth-moving operations where a single machine might move millions of cubic yards. Only a small number were ever built. They were too costly for most contractors. But where they were used, they became mythical. Operators described them as unstoppable. Even when abused, they did not suffer the usual failures. Electric components could be rewound, motors could be rebuilt, generators could be serviced like industrial power equipment. Decades later, some Letourneau electric crawlers still exist in mining museums and private collections. A few even operate in limited roles. Their survival proves how radically over-engineered they were. They were not bulldozers in the normal sense. They were mobile power plants on tracks. They were built not just to last, but to dominate. Number 2. Clark, Michigan. 125C. Clark, Michigan is remembered for wheel loaders, not bulldozers. But in the 1960s and 1970s, the company produced crawler tractors specifically for industrial environments. The 125C was one of them, and it was built for places no normal dozer could survive. Steel mills, slag yards, foundries. These environments destroy machines. Heat warps frames. Metal fragments shred tracks. Dust eats bearings alive. A normal construction dozer would last months. The 125C was built for this hell. Its frame was massively reinforced. Guards surrounded every vulnerable component. Cooling systems were oversized to survive radiant heat. Hydraulics were shielded. Track components were thicker than those used on comparable construction machines. This was not a dozer meant to grade dirt. It pushed glowing slag, scrap metal, and furnace waste. Operators ran them near molten steel. Sparks showered over the hood. Heat shimmered across the cab. And they kept working. The 125C was slow, heavy, and brutally stable. Every component was designed for survival rather than efficiency. Clark, Michigan understood that downtime in a steel mill was catastrophic. These machines had to work. Many 125Cs remained in service for decades. Even after Clark's crawler business faded, the machines stayed. Steel plants rebuilt them because replacing them was harder than repairing them. Mechanics fabricated parts. Frames were reinforced again and again. Few people ever saw these dozers. They lived behind factory walls, but they represent a kind of over-engineering that modern equipment rarely attempts, building a machine specifically to survive an environment that actively tries to destroy it. Number 3. Hough H180 Crawler. Hough was famous for wheel loaders. In the mid-20th century, it dominated industrial loading equipment. But when Hough built crawler tractors, it did not think like a normal dozer manufacturer. The H180 crawler was engineered with loader philosophy, heavy frames, massive axles, industrial durability applied to a tracked machine. The result was a bulldozer that felt more like a tank than a grader. Its structure was enormous for its size class. Frame members were thick and deeply braced. The undercarriage was overbuilt to survive constant impact. The machine was heavy, even without attachments. Hough expected these crawlers to work in quarries, mines, and industrial yards. They were not farm dozers. They were not light construction machines. They were industrial animals. What made the H180 special was its refusal to flex. While other dozers relied on controlled frame movement, the H180 stayed rigid. It transferred stress through steel rather than absorbing it. Cracks were rare, bends were uncommon. Operators reported that the machine felt solid in a way few dozers did. It did not chatter. It did not shudder under load. It simply pushed. Only a limited number were built. Hough's crawler line was short-lived, overshadowed by larger brands. But the machines that exist today are still running in private hands and industrial yards. They survive because they were built like industrial equipment, not consumer machinery. They were designed for abuse before abuse even happened. Number 4. Acco Super Bulldozer. In the early 1980s, Italian manufacturer Acco decided to build something no one else dared to attempt, the largest bulldozer in human history. It was commissioned for a Libyan oil and pipeline project that required pushing enormous volumes of desert earth in extreme heat. No existing machine was considered strong enough, so Acco overengineered everything. The super bulldozer weighed more than 180 tons. It rode on tracks wider than most pickup trucks. Its blade was nearly 23 feet wide. Power came from twin diesel engines producing over 1,300 horsepower combined. Every component was custom-built. Nothing was borrowed from existing platforms. This was not a scaled-up dozer. It was a ground-moving battleship. The frame was fabricated from massive steel sections, normally used in heavy industrial structures. The undercarriage components were so thick that replacing them required specialized cranes. Cooling systems were oversized to survive Saharan heat. The drivetrain was engineered to handle loads no commercial dozer had ever faced. Then politics intervened. International embargoes prevented delivery. The project was cancelled. The machine never worked in Libya, and yet it refused to die. The Acco Super Dozer remained preserved in Italy. It became a monument to over-engineering. Unlike many prototypes, it was fully functional. It was not a showpiece. It was a working machine that simply never got its battlefield. Today, it stands as proof of what happens when engineers are given unlimited freedom and a brutal mission. It was built without compromise, no cost-cutting, no weight targets, no marketing department interference. It is not just the biggest bulldozer ever made. It is the purest expression of industrial excess in earth-moving history. Number 5. Caterpillar DD9. Before electronics made power easy, Caterpillar solved the problem the old way. Add another engine. The DD9 was a twin-engine variant of the legendary D9. Instead of one power plant, it carried two diesel engines mounted side by side, each driving part of the drivetrain. The idea was simple: double the power without redesigning the entire machine from scratch. It worked. The DD9 became a monster. It delivered enormous pushing force while retaining the rugged mechanical DNA of the standard D9. Everything else had to be reinforced to survive the new stress. Frames were strengthened, final drives were upgraded, cooling capacity was increased. The machine was transformed into something closer to a mining tractor than a construction dozer. These machines were rare. They were expensive. They were built for extreme applications, quarries, heavy ripping, and specialized military or industrial work. Most contractors never saw one, but those that did remembered them. The twin engines gave the DD9 a unique character. It sounded different. It pulled differently. It did not surge. It crushed forward. Operators described it as feeling anchored to the planet. The brilliance of the DD9 is that it achieved extreme performance without electronics, without software, and without modern complexity. It was pure mechanical excess. When one engine failed, the other could sometimes limp the machine home. When both ran, nothing in its class could match its raw authority. Many DD9s were rebuilt multiple times. Engines were swapped. Components were cannibalized. They survived because they were built on a platform already known for immortality, then reinforced beyond reason. It was not elegant. It was not efficient. It was unstoppable. Number 6. Terex 8230. During the 1970s, Terex was synonymous with gigantic earth-moving equipment. The company produced some of the largest trucks and scrapers ever made. Hidden in that lineup was the Terex 8230 crawler dozer, a machine designed for mining and heavy industrial use. The 8230 was built with the same philosophy as Terex's haul trucks: overbuild everything. It carried a massive diesel engine, a reinforced frame, and a mining-grade undercarriage. This was not a general-purpose construction dozer. It was a pit machine. It worked in the shadow of haul trucks, pushing blasted rock, shaping benches, and clearing collapses. What made the 8230 special was how little it resembled a typical dozer. It was wide, tall, and intimidating. Its structure felt closer to a haul truck frame than a crawler tractor. Every component was scaled for shock loading. Terex expected it to work in places where normal equipment died early. Mines, quarries, remote projects. The machine had to be self-reliant. Field serviceability was built in. Major components could be removed without dismantling the entire machine. When Terex's crawler line disappeared, many 8230s were already deeply embedded in mining fleets. They were not replaced, they were rebuilt. Engines were overhauled. Undercarriages were replaced. Frames were repaired. Some of these machines remained in operation for decades after production ended. They survived not because parts were easy to find, but because the core machine was too strong to abandon. The 8230 is forgotten today because it lived in places few people ever visited. But in the mines where it worked, it earned a reputation as a machine that could not be bullied by terrain. It was built for war against the earth, and it never surrendered. Number 7. Orenstein and Koppel, D150, D170. Orenstein and Koppel, better known as ONK, was never interested in building comfortable construction machines. The company came from the world of railways, mining, and heavy industrial equipment. When ONK built crawler tractors in the 1960s and 1970s, they carried that same mindset. These machines were meant to work inside quarries, steel plants, and industrial yards where failure was unacceptable. The D150 and D170 were not designed to compete with farm dozers or road builders. They were industrial crawlers. Their frames were box-section steel structures that looked more like locomotive chassis than construction equipment. The undercarriage components were massive, built to survive rock impact and constant side-loading. Every hose, line, and fitting was protected. These machines worked in limestone pits, coal yards, and steel works across Germany and Eastern Europe. They pushed material that chewed through ordinary equipment. ONK expected operators to ram piles, shove slag, and climb unstable ground. What made these machines special was how little they cared about weight. There was no attempt to make them light. Stability and durability came first. They were slow, powerful, and immovable. Operators trusted them in environments where tipping or frame failure meant catastrophe. When ONK left the crawler tractor market, many D-series machines remained in service. Industrial facilities rebuilt them because replacing them required redesigning entire workflows. Their owners fabricated parts, adapted bearings, and kept them alive because nothing modern fit the job as well. These machines still exist in European industrial yards, scarred and ugly, but operational. They are monuments to a time when industrial equipment was built to last longer than the buildings around it. Number 8. Bucyrus-Erie, 50. Bucyrus-Erie is a name associated with giant draglines and shovels. When such a company builds a bulldozer, it does not think like a construction firm. It thinks like a mining engineer. The 50B crawler tractor was built with that mindset. It was heavy, rigid, and brutally simple. The machine shared design philosophy with Bucyrus-Erie's excavation giants: oversized components, conservative stress limits, and absolute mechanical reliability. The 50B worked in strip mines, quarries, and heavy industrial projects. It shaped benches beneath towering draglines. It cleared rockfalls. It maintained haul roads under constant punishment. This was not a dozer for grading parking lots. It was a pit animal. Everything about the 50B was exaggerated. The cooling system was enormous. The drivetrain was designed for constant load. The undercarriage could tolerate extreme wear. Bucyrus-Erie expected these machines to operate continuously in dust, heat, and vibration. When the crawler line ended, the 50Bs did not disappear. Mines rebuilt them. Engines were overhauled. Hydraulics were renewed. Frames were reinforced. The machines stayed because they were already paid for and still capable. Few people ever saw them. They lived in pits and industrial complexes, but in those environments the 50B became legendary as a dozer that could not be frightened by terrain. It was not famous. It was indispensable. Number 9. YTO. In the 1970s, China's heavy equipment industry followed a different philosophy. Machines were built for longevity in remote, resource-poor regions. The YTO T120 crawler tractor was one of the earliest heavy export dozers built under that system. The T120 was based on Soviet-style engineering principles: thick steel, mechanical systems, low-speed torque, and absolute simplicity. There were no electronics, no fragile components. Everything could be disassembled with basic tools. These machines were exported across Asia, Africa, and parts of Eastern Europe. They worked in agriculture, land clearing, and infrastructure projects where modern support networks did not exist. Operators often had no access to genuine parts. That did not matter. The T120 was designed to survive improvisation. Bearings from trucks were adapted. Hoses were fabricated locally. Worn gears were remachined. The machine tolerated it all. What made the T120 over-engineered was not power, it was forgiveness. The design allowed abuse, neglect, and creative repair. It did not demand perfection, it accepted survival. Even today, T120s still operate in rural regions. They maintain roads, clear land, and push soil for small communities. They exist because they were never dependent on a factory. They were built for a world without guarantees. Number 10. Krupp-Dolberg KD-160. Krupp-Dolberg built machines for one purpose: surviving in quarries. The KD-160 was a crawler tractor that looked more like a mobile fortress than construction equipment. Its frame was heavily plated. Its undercarriage components were enormous. Guards surrounded every vulnerable system. The machine was designed to work among falling rock, abrasive dust, and constant shock. The KD-160 was not fast. It was not refined, but it was nearly indestructible. Quarry operators trusted it in zones where collapse and impact were routine. It pushed blasted stone, stabilized walls, and shaped terrain beneath crushers. Krupp-Dolberg expected these machines to work for decades. They were priced accordingly. Owners treated them like infrastructure, not tools. When production ended, the machines did not vanish. Quarries rebuilt them because replacing them meant redesigning operations. Mechanics kept them alive with fabricated parts and heavy welding. Some KD-160s still exist today, parked beside crushers, scarred by decades of stone. They remain because nothing modern fits their role as well. They are not dozers, they are bunkers on tracks. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.